going to have it up there? Maybe?
Possibly.
No,
I mean,
you can look it up, but it should be.
Okay. So welcome to the Synergy Science Podcast tonight. We have a very special guest tonight. We in the same vein as we were breaking ground with bringing Lily Fighter on, the first female to come on a New Holstein podcast, we have Mr. Doug Kestell, who's our school board member here tonight, and he's also a scientist. Doug, why don't you just tell us a little bit about yourself and tell all our viewers, I mean, there's literally dozens out there tonight. Tell us a little bit about yourself and your interest in science and what you do, besides being a school board member.
Absolutely. Long story short, as Mr. Rupp has said, I'm a school board member here at New Holstein School District. I'm an alumnus from New Holstein as well. I had my science epiphany with Mr. Anderson in 7th grade when he was teaching biology class, and up at the elementary school, and at that moment I knew I wanted to become a biologist, and I pursued that through the rest of my high school career. Into college I became a biologist, studied tropical ecology, worked for the Smithsonian Institute for a while, went into auto and aerospace engineering, and currently work somewhere between process engineering, material science, and project management. I'm currently on the school board, and I was asked to come, and I was more than happy to oblige. So I'm excited to be here.
Yeah,
thanks for the invite.
It's
and
great.
Thanks for coming.
Yeah, it's going to be
We
great.
just have a lot of fun discussing awesome science topics, and we are down a man tonight. Max actually was not feeling well, and he went home sick. So I know if you're here for time travel, you're going to have to wait till next week. So I think what we're going to do is Ethan's going to give us a quick update on a story we talked about 2 weeks ago.
Yeah.
Very interesting.
So it's the robotics topic. So 2 weeks ago I talked about Boston Dynamics, which is owned by Google, and they created an Atlas robot, and it talked about the DARPA Robotics Challenge. And here's an update. This is a new version of the Atlas robot that was used in the DARPA Challenge. So I'm just going to play a quick video. So unlike the robots in the DARPA Robotics Challenge, this robot is not falling over very much, if at all. And it can even walk on snow.
it looks like it's way faster too.
It's also much smaller. It's only 5 feet 9 inches tall and weighs 180 pounds.
The DARPA Robotics Challenge, was last year the first year of that?
Last year was the final, so it went on a few years, and then it was the finale.
So they're not going to move forward with another challenge or anything like that?
Not in the plans now.
So now it's just people doing their own thing.
Yeah, so I think, when I look back to when DARPA started the Grand Challenge, which was trying to drive autonomously from like Las Vegas to Denver or something, I can't remember what it was, but this is really, really preliminary autonomy, computer autonomy kind of things, and it's come a long, long way. I kind of comically, there was a YouTube blurb about this folks trying to do the same thing in Russia, and they had a mannequin on a four-wheeler, and the guy was using a remote control with Vladimir Putin going, really, this is all the better we can do? So this is just absolutely amazing. I bet, people in the world just go, oh my God, really? It's almost creepy, right?
I was telling Ethan this. I want them to put some artificial intelligence in here, so that when he does that, I want that robot to be like, dude, really? I'm like, now, like,
You might not want that.
Or kick the box,
or,
right?
Yeah, or punch him. I want something like that. I want these robots to have a little more personality, so they get, show some anger.
Yeah.
But I mean, look at that. He's lifting with his legs, not his back. Look at this. Seriously, I don't like this. But this, here's amazing.
It's crazy.
Shoots himself up.
It's a lot easier to make things move on wheels. The balance is.
Earlier, you had it up. It reminds me, it's like the Jetsons.
Right.
Doug, you remember that?
Yeah.
So we got to. What was her name?
Lucy, right?
Lucy. We got to get some of those around our house.
I just think being able to carry its own power, right? A lot of those you saw preliminarily, right? They're on a treadmill with this big wad of cables, and now they're just carrying it by themselves. It just blows me away.
Okay. Well, that's a great update. Thanks for that, Ethan. So I think at this point, Isaac, is going to
Talk about virtual reality.
virtual reality. This should be exciting.
I mean, yeah, it's a reality, folks.
Yeah,
It's
it's,
virtual.
it's a real virtual reality.
Yeah, it's a real virtual reality.
Okay.
So virtual reality. I don't know if you've heard of it or not. It's you basically have this headset that you plug into your computer, and then you see stuff like you can see a forest or whatever, anything that you would typically see on a monitor, but now like it's on your eyes. It's basically like seeing it in real person. Like you can move your head left and right, and it would do the same thing as if you're in person.
Cool.
So it's basically reality, but virtual.
Is this just for gamers?
No, it's not just for gamers. Like there's a whole social aspect to it. Like you can do a whole lot of stuff with it.
There's also applications like medical applications for like neurosurgeons to have this interface in front of them while they operate a machine.
Okay.
And there's going as
I'll get into some of the companies that are leading the charge. Valve, more commonly known as Steam, they're working on a virtual headset. Microsoft, they're a big one too. They also have augmented reality. Ethan, do you want to enlighten us on that?
Yeah, so Microsoft has a thing called Microsoft HoloLens, which is kind of the same thing, but you can actually see what's in front of you with an overlap, which is the virtual reality. So you can have projections in your vision. It's kind of like an amplified version of the Google Glass. And this is going to be really powerful because you can look in front of you and you can see a car in your living room, or like that's just an example of how much you can perceive that's not actually there.
Some more companies are Sony. I'm sure all of you have heard of Sony. They're doing it. They also make the PlayStation, which is kind of part of the reason that they're doing it. Oculus, they were kind of like the founders of it, like Oculus Rift. That's their headset name. They were pretty much the first to do it, but now Facebook bought them a while back, and now Mark Zuckerberg is kind of going gun-ho, leading the charge. Oculus is probably the furthest in the whole virtual reality scale, but Google's also in there, and so is Samsung. But the headset itself, there's a picture on the left. That's sort of like what you would see if you just put it on and wear it. And then there's just like each of these different companies that I just named, they all have different models. Like the bottom one, I believe that is Samsung. And then the top one, I think that one's Sony's. And they all look different, but they basically function the same.
So, like, eventually, you're talking like PlayStation. That's like a Sony thing.
Mm-hmm.
Are they developing this to like use in one of their gaming systems so that the games will be, you can be like more into the game? Is that sort of what they're going to do?
Definitely. Like, you can just plug it into your PlayStation or whatever, and rather than seeing it on a TV screen and looking left and right, you can just move your head and look left and right.
Do you think you would still use like the controller, or it would eventually kind of get where it's like you can mimic the body motions you would do with it and actually be in the game? What do you think? I don't know.
Well, I don't know if you've heard of Microsoft Connect. You
Yes.
know?
Mm-hmm.
I'm sure like you could pair the two up, and then it's basically like you're playing the game.
Yeah, they're definitely working on that, like exoskeleton games too,
Mm-hmm.
as well, like where it can restrain your freedom.
I'm just wondering, I can speak to this and you can speak to this because we're a little bit older. Kids today are really into their technology, into their games. I guess I'd be a little bit worried that like putting kids in their headsets and letting them go into a virtual reality. Like, what about reality?
Yeah.
And I mean, how are we worried that we're going to be so into the virtual reality? I don't know. What do you think?
Yeah, I guess, but then again, there were also people who said, yeah, that darn automobile, who's making the horseshoes, right? I think that there's this term called neo-Luddites, right? People who hate technology, right? And there was this Luddite revolution years and years ago around the cotton gin, because people who did it by hand didn't want to do it. Right. I think, the virtual reality thing, that there's always that worry, right, that people will just live in that virtual world. But I think it's almost how we treat cell phones and things today, that if we actually teach people and use it for positive things, right, for engineering or medicine or even just for entertainment, got to come up to breathe once in a while,
exactly.
right?
Yeah,
I'd hope at least. I don't know.
Gotta come up and get a sandwich.
Right, exactly. Unless there's a virtual sandwich out there, but I guess not, right?
That's cool.
Almost everything we talk about has its positives and negatives.
I'd agree. Yeah. I was interested when you said about the surgery. So, like, would a surgeon be seeing, like, if let's say they're doing brain surgery, would they be seeing the actual brain that they're operating on? So they,
I believe so,
right in
yeah.
there.
And there's different, like for augmented reality, that's where you can see what's in front of you.
Okay.
You can have data being overlapped on your screen to know different temperatures or sensor readings from
That's
the
cool.
body.
So there's a lot of applications that way too.
You're right.
I'd imagine like a great heart surgeon in South Africa could work on Ethan in Milwaukee,
Yeah.
right, and not have to be there. You know what I
Wow, I
mean?
never thought
You know
about
what I mean?
that. Controlling
Right.
robotic.
Right.
Yeah,
They have
real time,
machines
virtually.
for that.
Right.
What I wonder about if there's any military training applications where you could set up scenarios in virtual reality where you could be training.
Yeah,
There's
actually, along those lines, when I was in DC 2 summers ago with my uncle, I had the opportunity to try a simulator with using the Oculus Rift.
Okay.
So what it was a flight simulator where I could test out an airplane.
Wow.
So it had the sensors in front of me, and then I put the glasses on, and when I turned left and right, I'd see out the left window and the right window. So, just
Well, and you think like even like in education, like a virtual field trip. If you had 25 of these in your thing, let's go to the coral reef. Somebody's been there, they did it, and you. But I don't know if you could actually do live time, but you could do. Let's go to the Great Barrier Reef, and we could actually be scuba diving in the Great Barrier Reef. I mean, that would be pretty cool. Let's get that on the budget,
It would be.
Get that
It'd be
going.
cool.
Okay. I mean, you like
It'd be cool.
science? We got
Absolutely.
science budget's going to be going through the roof.
It has to. It has to.
That's cool. That's cool. I think.
All right, so now we're gonna sort of get into how it works, but we're not gonna go too far into it because obviously it's way more complex than we can do in an hour. Well, obviously we're not gonna take an hour on it, but
I'm still a little shocked that you're not doing some chemistry this week.
yeah, I know. There's not a whole lot going on in the chemistry
Oh,
news
what's the chemistry
right now.
lot?
I don't know. That's
Augie would disagree.
It's probably.
I mean,
Okay,
there's
tell us how it works.
So let's see here. We got the gyroscope up there. That's kind of the main deal. Like, look left, and then you see left. Look right, you see right. A gyroscope, how it works. That thing in the bottom right there, that would be an auxiliary gyroscope, like not a digital one. So, a good example would be globes. Like how you can spin a globe left and right, and then it spins on that axis. But you can also spin it up and down, and then you can spin it in circles and even at diagonals.
Gotcha.
But how a digital gyroscope works, it's almost like there's a little ball in there, right? And a sensor recognizes which way it spins, and then it takes that information and it puts it into the computer. So you can tell, like, oh, he's looking left.
There's a gyroscope in everyone's pocket too.
Yep.
Each phone has. It probably has one.
My slider? Maybe.
Probably.
Okay.
And along those lines, like there's some apps where you can use a level and move it left and right until you get centered. That's the gyroscope in action.
Cool.
And Google has a thing called Google Cardboard, which you can put your phone into a piece of cardboard and move your head left and right, and it'll show like images and videos. So.
Interesting.
Well, that also, and so that's how the gyroscope works, but everything else, like the stuff that you actually see, that's all based on monitors. So like your computer monitor, right? That's the exact same how it works. I'm sure we'll explain it later, like the LCD, liquid crystal display, and the LED, light emitting diode, all that stuff. But right now we're just gonna go pretty shallow into it.
Okay.
Obviously it's like, wow, this is pretty cool. When will it be available? And as you can see there, that's Facebook's Mark Zuckerberg. He gave a seminar to a whole bunch of people. I believe it was in Barcelona, Spain. And everybody was wearing virtual headsets from Oculus. And it's pretty cool to just see like a seminar with everybody wearing that. Might look.
Do you know the price tag on one of those virtual reality, like the Oculus, whatever you called it?
Now they just came out for pre-order right now.
You can pre-order them. I'm not like super sure of the prices, like all these different companies too.
Sure.
You know how much they are? About $100 it looks like.
Okay.
So it's not like it's gonna break
That's
your bank.
Samsung gear.
Yeah, that's for Samsungs. But like, I mean, that's really cool just to see a seminar. But Since you can pre-order them,
For the Oculus Rift, it's $600 for pre-order.
so pretty hefty price.
And then so with that, they'll be like automatically built in, it's programmed or software, or it's just like all on your computer.
Right now, it's kind of a lot in development. Like, the developers want it, but it's becoming more and more for the consumer.
Cool.
The official date is March 28th of this year for the Oculus Rift. Oh boy, what company was it? HTC Vive. They just came out with theirs as well. I'm not 100% sure of when that's going to be released, but very soon. I think that one is already released, actually. That's pretty much it for the
Alright.
virtual reality.
I want to ask one question. Did you say, Ethan, something about like putting it in your contacts or something? Is that something in development with virtual reality instead of having the big? Could you actually like get it into your contact lenses or?
That's probably the next step.
Next step.
Yeah,
Like
like
the augmented reality right now is just like an overlap where you put glasses on,
Oh, the Google Glass.
but it projects something over the glass.
like if you think about it, sort of like with the cell phone, you know, it used to be really big, right?
Yeah.
And now it's fits in your pocket.
Gotcha. Okay.
So like I'm sure it'll get smaller with time.
So within a couple
Nanotechnology.
years, we're going to start seeing this here, and people will be using this.
Mhm.
Okay.
Reminds me of Viewmaster. Remember
Yeah,
those?
yeah.
You guys ever
That's a
see
virtual
those?
reality,
Yeah.
right?
Yeah, it was. You know, it was 3D. It was so crazy.
Okay.
Alright.
Ethan's going to get into his
Nanoscience.
Nanoscience. Here we go.
Alright, so this summer I took a course in nanoscience at Carnegie Mellon University, and I figured I should share what's going on in nanoscience because I found it really interesting. So first of all, what is nanoscience? Nanoscience is the study of extremely small things that can be used across all other science fields such as chemistry, biology, physics, materials science, and engineering. So essentially nanotechnology refers to very small applications for all aspects of science. So how small are we talking? We're talking about a nanometer, which is, let's see, it is 1/1000th of a meter, which is pretty small. It's like comparing a grape to the earth, which is pretty small. It's also like saying a nanometer is 100,000 times smaller than a strand of hair. So it's kind of small and hard to imagine, but it's down there. What makes nanoscience really hard to work on is you can't see it. Like when you're building a bridge or a car, you can see what's going on in front of you. But in nanoscience, you're doing that all through a different perspective. You're looking through microscopes and yeah. All right. So that's what nanoscience is, and I'm gonna talk about why it works.
Can I cut in for a minute?
Yeah.
This reminds me, this picture right here, I have to have a shout out to Calvin Leverins
Rubik's
because he
Cube.
solved the Rubik's Cube in 1:47 for me. Remember he said 2 weeks ago he
Yeah.
could solve it in under 2
Yeah.
minutes? He actually did it. That reminded me of the Rubik's Cube. So I told Calvin I'd have a shout out
Did
to
you
him.
solve the one on the right?
The one he solved in 1:47 was the
one
one
I
on the
would
right.
solve,
So he still has to step up and do the real one yet. No, Calvin did it. Good job, buddy. All right, back to nanoscience. Nothing to do with nanoscience there.
Right. So the ratio of like bulk volume versus surface area changes as objects get smaller. So the surface area to volume ratio is going to be smaller in a larger object because the volume is greater. However, when you get to a small object, like very small, like nanometer size, the surface area at like a discrete point, it actually starts to significantly outdo the volume. So surface area becomes much more prevalent than the volume. So all the aspects of surface area, which include more energy, outweigh the volume, which is the bulk material. So you get totally different properties.
It's kind of interesting because I'm always, as a biologist, we're thinking about, why does the cell have to divide? If it's too big, its surface area can't keep up with the volume. And now we're kind of going just the opposite of that, where it's like, well, we have such a surplus of surface area, you know what I mean, that
Sure.
what can we do with it?
But it's the same reason why from an evolutionary standpoint, most organisms get smaller when you get to warmer temperatures for the same reason they have to get rid of energy.
Oh, yeah.
So when you have a smaller volume to a larger surface area, it's easier to get rid of that
Dissipate it.
excess metabolic energy. So big animals are more north.
Right.
So what are you saying about bigger humans? Where do I fit into this?
All right.
That explains the 5 pounds every winter.
I guess.
So what happens when it gets to the small stage? In the top right picture, this is called a boundary. So it's like a grain boundary, and what this is an imperfection in the solid. So this is like a surface area within the bulk volume. So like just anything, like this table is going to have a bunch of imperfections within it, which expose atoms to in their non-lowest energy state. And along those lines, all the atoms on the outside of a surface have much more energy. So when you get smaller, you are filled up with the outside energy compared to the middle. And this excess energy creates properties like scattering of light and absorption of different radiation. It also makes it frictionless, so nanoparticles are frictionless, and they sink in water, and their melting properties decrease rapidly because there's more energy. It'll melt faster. It becomes extremely fast with the frictionless. Like if you have rotary applications, the rotors will spin rapidly, and all the properties just change tremendously. So what you can do, you can start using these different characteristics for different applications. Like in this bottom right picture, you see this liquid not sticking to the surface because the surface is most likely coated with a nanomaterial that does not allow for it.
So it's sort of like the difference between concrete and glass. Like a concrete surface is really rough, and glass is really smooth, right?
Right. And like a lot of the nanoscience today is used for coating materials.
I was gonna say, I was thinking like coating pans,
Yep.
something like that.
Non-stick
pans. Never even considered that would be something you would use nanoscience for.
Yeah, I just put this picture of Ant-Man because when you get small, it gets stronger.
Yeah. So they do a lot of this in auto and aerospace example is they use plasma treatment, right? So you have a machined metal part or any kind of metal, let's say, that's exposed. And if you expose it to different atmospheric conditions, typically, right, it's isolated from ambient atmosphere, but you pump in nitrogen or different types of gases and subject it to really high electrical forces, it'll change the surface energy of that metal so it doesn't corrode or it has high slip or it has a lot more wear resistance and all those kinds of things. So there's actual real time, everyday applications that they do this. You know, a great example is they do this in the differential gears in the back of every car and truck you see out on the road has that kind of plasma treatment that affects it at a nanoscale. That's very cool stuff.
So just because it's small doesn't mean that it's not everywhere you look.
Gotcha.
And only one atom thick, right?
Yeah. All right. Some medical applications. Nanoscience is really useful for detecting diseases in unhealthy cells because when a cell gets unhealthy, it releases something called biomarkers, and nanoparticles can be manufactured to detect these particles. So essentially what you can do is detect if you're sick before your body can detect if you're sick. So that's what is going on in some medical applications, and Mr. Rupp's going to talk about that further later in this podcast. Another point of reference is that blood cells are about 7,000 nanometers thick, and compare that to a nanometer, you get a huge difference. So we can use these small little devices to help our health. I don't know if you guys want to add anything to that.
No, I think when I get into
Sounds
mine,
good.
it'll make more sense later with the medical too.
Quantum computing, which is right now it's very complicated and complex. Not many people understand it. At the University of Berkeley, what they are proving is that they can zap an exotic silicon material with microwaves, and what they're doing is getting the electron spins to go from an excited state to relaxed state, or relaxed ground state, and this, as it goes down from the high level to low level, it releases photons, which is energy. And an interesting thing about this is today's computers are made up of classical bits right here, which is a 1 or a 0, so it's binary. Like in my computer, there's just billions and billions of ones and zeros that do all the computation behind when I open up Google. That's what's going on with the classical bit computer of today. However, what a qubit is what they're using for quantum computing, which is the nanoscience, very small aspect of manipulating atoms. What they can do is actually have like a transitional state, so it's not just 1 or 0, you can have in-between states. And what this is going to allow is simultaneously calculating different calculations. So this simultaneous action is going to allow much faster processes than our computers today. And the NSA, which is the National Security Agency, announced or made a statement recently that they need to create better software or encryption that can protect from this, because once someone gets a supercomputer, which is the quantum computer, it's going to be so much more powerful than today's computers. And the problem is, how are we going to defend today's computers against a supercomputer that can do all this calculations and decrypt your encrypted computer?
Interesting.
So that's going to be a huge issue.
So yeah, they could go through every possible code in a matter of a nanosecond.
Right, because our computers have a latent period between issuing a command, going through the whole code length. If you can do that instantaneously or cut that to a fraction of the time, you just run circles around our stuff.
And just like what we talk about, it's not actually that far-fetched, because many companies are working on this in universities, and Google announced that it's in a couple of years it'll have a quantum computer that can be useful for applications. So
I wonder if it'd be more efficient energy-wise too, right? That's the killer of most computers today, right? They just consume a huge amount of energy, and if you could minimize that, it becomes an efficiency thing too. I wonder.
Nuclear fusion, that's a lot of energy right there. If we could harness that.
Okay.
All right. So another application is carbon nanotubes. So nanomaterials made of carbon in tube shape, and these carbon nanotubes are stronger than steel and Kevlar. So in this picture right here, you see a bulletproof suit, and it's 50% lighter than Kevlar. So Kevlar is the material used for armor or bulletproof vests in the military, and this is 50% lighter, so you can wear it casually, and people won't know that it's bulletproof.
James Bond.
Yep.
And carbon nanotubes are 117 times stronger than steel and 30 times stronger than Kevlar. So it's lighter, yet it's better.
Sort of like titanium and spider silk. I don't know if you guys have heard about spider silk.
I know spider silk is one of the strongest things, right?
Yeah.
You need Ryan Wagner to come tell us.
Okay.
Yeah. I'll probably talk about that in a couple weeks.
Okay.
Upcoming weeks.
Do it. So when would this sort of thing be on the market?
I believe it is already.
Oh,
Yeah.
okay.
I'm sure it's expensive, but for those who want the protection, we might as well, I guess.
Putin?
Yeah. Don't they? And I'm just thinking about the stuff I've been around that is made out of carbon fiber, right? You know, and I'm thinking about the Australian Cup sailboat that it's not Rolex who owns it. Tag Herrera owns it. That goes at 110 miles an hour in the water on hydroplanes. That thing's made out of carbon graphite, and it weighs a tenth of what a conventional sailing ship did, 10 years ago.
We should get this in. We should use this for our What's our high energy car we're trying to build? Let's get Wagner on this. They should build some carbon nanotubes.
Yeah.
Augie, and we could get Augie to start manufacturing these in chemistry. And get Wagner to build this high energy car or whatever they're building.
Yep.
So that's something to look for here.
Yeah.
All right. So I'm just gonna play a few minutes or a few seconds of this video because it has some cool applications that you can just get from looking at it. So one side must be coated, the other is not, so the liquid just flies right off. That has to do with the imperfections like I talked about.
just so many possible applications.
That's where my head went, is right, one of the biggest killers trying to come back in, right? If you have a really high slip coating on the outside of like a spacecraft, right, would it not generate as much frictional heat, and could you do that easier?
Yeah.
Not have as much insulation, not much,
Right.
because you have to bring that stuff up in space to help you get back through again, right? I just wonder.
Yeah. That would take less energy to get there too.
I'm just wondering if we could somehow use this at the new Holstein Water Park to put on the slides, because that crack, you go on those water slides?
Yeah.
When you hit that
Oh,
crack in
yeah.
your back, it hurts a little bit. We should get that nanotechnology to seal those cracks.
Kid ends up in the woods across the street.
Yeah, it'll be like Clark Griswold. I think that's what he
I
used.
think that's
Clark
what he-
Griswold used
oh,
that
yeah.
in National Lampoon's Christmas Vacation to go down on the sled. It probably was, to be honest.
Cooking oil.
Yeah, I think it was nano oil.
Oh, yeah, must have been.
Must have been.
Speaking of sliding, this is a space elevator, which is kind of a theory right now, and they're working on it, but it's not there yet. It's a prediction of where nanoscience is going. What this is using a carbon nanotubes, you can connect one end of this really long nanotube to the Earth and the other end to a counterweight up in space, and this will create kind of like a rail for spaceships to slide along to go up and back from going into space and coming back onto Earth. So it's not there yet, but because this nano cable is much lighter than steel and all other materials, it's becoming more and more of a realistic possibility. So there's that. Another interesting thing is an invisibility cloak, like Harry Potter right here. We're getting there. All right, at the Berkeley National Laboratory, they've created, so these two images right here are from the Lawrence Berkeley National Laboratory, and what they've created is a thin film consisting of a 50 nanometer thick layer of magnesium fluoride topped by a varying pattern of tiny brick-shaped gold antennas, each 30 nanometers thick. So very small, a sheet that you can place over an object. However, these objects that they've placed the sheet over have been very small and only been through like a microscope. But we know where the technology is going. If we can prove it micro scale, odds are we can bring it to macro scale. So what this is it reflects the patterns of light. So when you look at the object, you're not going to be able to see it's there. And I think this one they talked about having a mirror, so it like scatters it back and it mirrors it. But I think there's other ones that have it so when the light hits it, it wraps it around and you can see what's behind it. Yeah.
So that's kind of what you're looking at in another picture. There.
Right. So this is just kind of an illustration of what it will be. This is not a real thing right now, or not quite. So yeah, invisibility cloaks are becoming real.
Interesting.
And then military is obviously a fan of this because they can place something over their tank and it disappears.
Yeah.
Nanobots, which kind of ties into the medical applications, is using these nanobots, which are very small, to head into your body and act as mini surgeons and help that way. A guy from MIT named Nicholas Negroponte, sorry if I pronounced that wrong.
He's probably listening.
Probably must be.
He believes that we'll be able to use these nanobots to receive information and knowledge directly from these nanobots into the brain and from within the bloodstream. So, like another guy is an inventor and scientist named Ray Kurzweil, who predicts that we'll be able to connect to the internet with our brains and nanobots by 2030, which is not far away. And so what these nanobots are going to allow is simultaneous communication within your body, and it's going to be able to, you can program these microbots, nanobots, to go in with the right antibodies or whatever it needs. You could have tools to cut DNA at that small level. You can program it to do that, and it will do that at a much more efficient level than we can at a macroscopic scale.
It'd be kind of cool if you could just like program a few of them and put in your body, and then they could just like monitor everything, all your different systems, and be like, all right, you know, we got a problem going on here, or we're going to fix this, or you need to go in and get something else taken care of. Kind of interesting.
Right, that's what they're talking like with the brain, like right here, nanobot, and if you just put those in your brain permanently, they're not going anywhere, and if you can use them for more efficient processes, it's kind of like today we have a cell phone and we've gotten smarter, I guess you could say, with having this information that we could tap by punching in a few letters on our phone or texting, communication that way. If you can do this without having a phone in your hand, they're saying, why can't you do it without having a phone in your hand and using these nanobots to connect you to the internet?
Although if you put this small stuff in your body, right, like sort of like viruses, right, your body doesn't like them and wants to kick them out, I wonder if this would do this to the technology?
If they knew they were there, they'd probably try.
Yeah.
I wonder if there's some connection we could make. Like last week we talked about the spinal cord, the bionic spinal cord, and bypassing sort of a severed spinal cord. But I wonder with nanotechnology if there's some way you could actually use like some type of nanofiber that could actually connect the neuron to the muscle. Let's say that you know where it's been severed. I don't know what that material would be or how it could transmit.
Yeah.
But you know, think about it, because you're talking about these tiny things. They could probably easily thread them through, you know, that space. That'd be interesting.
Right. Because if these are that small and you can program it to do different tasks, that's going to open a whole new realm of possibilities.
By the way, if anybody listening is, you know, just recently developing that, you know, give me some credit. I just thought of it.
Yeah. And this is from Disney's movie Big Hero 6. It's kind of like the nanobots, but much smaller, and using those to create swarms in your body and helping that way.
Cool.
All right, that's it.
All right, so this is actually going to kind of piggyback to a lot of what Ethan said in a sense, but this is actually just released yesterday. Ohio State University has some researchers that had discovered a new possible treatment for cancer, and what they're using is they're calling a DNA Trojan Horse. And so obviously we all know the story of the Trojan Horse. And what you're seeing there on the left side of the picture, these are small pieces of DNA that have been synthetically made through it's a nanotech process. It's called DNA Origami. And what they're going to do is they're going to load them up. So on the left you're seeing the hollow DNA tubes, and on the right you're seeing them loaded up with medicine. And what they're going to do is they are going to use these little DNA Trojan horses to take drugs to a cancer cell. Before we get into like what they're actually doing with it, I want to get into this DNA origami a little bit and talk about how you can fold DNA. So Ethan, can you go ahead? Yep. We'll show the origami video and then we'll come back. This is phenomenal right here, folks.
There's an ancient and universal concept that words have power, that spells exist, and if we could only pronounce the right words, then, you know, an avalanche would come and wipe out the hobbits, right? So this is a very attractive idea because we're very lazy, like the Sorcerer's Apprentice or the world's greatest computer programmer. And so this idea has a lot of traction with us. We love the ideas that words, when pronounced, they're just little more than pure information, but they evoke some physical action in the real world that helps us do work. And so, of course, with lots of programmable computers and robots around, this is an easy thing to picture. So how many of you know what I'm talking about? Raise your right hand. Okay, how many of you don't know what I'm talking about? Raise your left hand. Okay, all right. So that's great. So that was too easy. You guys have very insecure computers. Okay. So now the thing is that this is a different kind of spell. This is a computer program made of zeros and ones. It can be pronounced on a computer. It does something like this. The important thing is we can write it in a high-level language. A computer magician can write this thing. It can be compiled into zeros and ones and pronounced by a computer, and that's what makes computers powerful, these high-level languages that can be compiled. And so I'm here to tell you don't need a computer to actually have a spell. In fact, what you can do at the molecular level is that if you encode information, you encode a spell or program as molecules, then physics can actually directly interpret that information and run a program. That's what happens in proteins. When this amino acid sequence gets pronounced as atoms, these little letters are sticky for each other. It collapses into a three-dimensional shape that turns it into a nanomachine that actually cuts DNA. And the interesting thing is that if you change the sequence, you change the three-dimensional folding, you get now a DNA stapler instead. These are the kind of molecular programs that we want to be able to write, but the problem is we don't know the machine language of proteins, we don't have a compiler for proteins, so I've joined a growing band of people that try to make molecular spells using DNA. We use DNA because it's cheaper, it's easier to handle, it's something that we understand really well. We understand it so well, in fact, that we think we can actually write programming languages for DNA and have molecular compilers. So then we think we can do that, and my first question doing this, or one of my questions doing this, was how can you make an arbitrary shape or pattern out of DNA? And I decided to use a type of DNA origami where you take a long strand of DNA and fold it into whatever shape or pattern you might want. So here's a shape. I actually spent about a year in my home in my underwear coding, like Linus in that picture before. And this program takes a shape, spits out 250 DNA sequences. These short DNA sequences are what are going to fold a long strand into this shape that we want to make. So you send an email with these sequences in it to a company, and what it does is the company pronounces them on a DNA synthesizer. It's a machine about the size of a photocopier, and what happens is they take your email, and every letter in your email, they replace a 30-atom cluster, one for each letter, A, T, C, and G in DNA. They string them up in the right sequence, and then they send them back to you via FedEx. So you get 250 of these in the mail in little tubes. I mix them together, add a little bit of salt water, and then add this long strand I was telling you about that I've stolen from a virus. And then what happens is you heat this whole thing up to about boiling, you cool it down to room temperature, and as you do, what happens is those short strands, they do the following thing. Each one of them binds that long strand in one place, and then has a second half that binds that long strand in a distant place and brings those two parts of the long strand close together so that they stick together. And so the net effect of all 250 of these strands is to fold the thing into the shape, fold the long strand into the shape that you're looking for. It'll approximate that shape. We do this for real in the test tube. In each little drop of water, you get 50 billion of these guys. You can look with a microscope and see them on a surface. And the neat thing is that if you change the sequence and change the spell, you just change the sequence of the staples, you can make a molecule that looks like this. And, you know, he likes to hang out with his buddies, right? And a lot of them are actually pretty good. If you change the spell again, you change the sequence again, you get really nice 130 nanometer triangles. If you do it again, you can get arbitrary patterns. So on a rectangle, you can paint patterns of North and South America or the words DNA. So that's DNA origami. That's one way. There are many ways of casting molecular spells using DNA. What we really want to do in the end is learn how to program self-assembly so that we can build anything, right? We want to be able to build technological artifacts that are maybe good for the world. We want to learn how to build biological artifacts like people and whales and trees. And if it's the case that we can reach that level of complexity, if our ability to program molecules gets to be that good, then that will truly be magic. Thank you very much.
So it was interesting because we typically think of DNA as just being this molecule that stores genetic material. And it's the molecule of heredity, and it has the instructions for making protein. And it was guys like this that said, you know what, I wonder what else we could do with DNA. Like DNA is this, it's just a molecule, it's a polymer, it's actually very simple, and it folds in predictable ways. And so realistically, let's try to build stuff with it. And I think it's kind of interesting. In the beginning, it was kind of this novelty, like, can we make a smiley face? Can we make a star? Can we make this? But at the end, he said, you know, I don't even know what the application will be. What do you want to make with it? And so now, after scientists have learned that we can fold DNA, we're going to start using DNA in ways that have nothing to do with heredity, nothing to do with genetics. We're just going to basically use DNA to build things. And so this is called DNA origami, and what happened is with cancer cells, they tend to develop resistance to our drugs. Okay, and so the Ohio State researchers, that's a football thing, right? Yep. So the researchers at the Ohio State University were interested in working with leukemia that had become resistant to a drug that was really good at killing it. And what would happen is if they gave it the drug, the cancer cells would actually pump it back out. It had like it had developed this way to pump the drugs back out. Almost, they said it was almost like a sump pump in your house. And so the drug would just be kicked out and it wouldn't do anything, and the cancer cells would live on. So what they did is they engineered these little DNA nanocapsules, and the dimensions are 15 nanometers wide and 100 nanometers long. And Ethan kind of talked about what a nanometer is, so that kind of helps. And within that were 4 hollow compartments. And so the way that the drug works is that this drug likes to get into the crevices of the cancer cell's DNA, and then basically stops it from copying itself. And so therefore, if the cancer cell can't copy its DNA, it can't multiply. And so what they designed with this little nanotube of DNA is that let's make lots of crevices for this drug to sit. So then what happens is they will put the little DNA capsules, the Trojan Horse they call it, by the cancer cell, and the cancer cell will actually think it's food. It will take it up, and then it will sort of be taken into the cell, and it just sits in there for a while until the cancer cell, I guess, kind of lets it get past its defenses. Then the DNA capsule will break down, and the drug will be released, and within 15 hours, the cancer cells have died. So we're looking at cells that were previously completely immune to certain medicines. They had had a resistance to that, now being killed within 15 hours just because of delivery. And so you're taking this thing, which really, I think 5 years ago we couldn't have even fathomed what any use of DNA besides just it's in cells and it has the genetic material. Now we're using it to build things. So it's a great piggyback onto what Ethan did there. I don't know. What do you guys think about that?
So with the Trojan Horse, are they programming the route that the capsule takes, or?
They're actually just kind of letting nature take its course. I mean, that's the thing is, like, we know that cells will take things into their surroundings, and so basically they just kind of let nature take its course. And so what they're saying is the trials, they tried it in mice and it was working really well. So they're going to try to get it into human trials, and their thought is that really this could be used in almost any form of cancer, not just leukemia. But it's a real step forward to using DNA in a new way.
Right.
And I don't even know where we could go from here, but you can see all the cool things they can make. So I think it's pretty neat. So I just thought I saw that news that was just released yesterday, and I thought, man, that's
When was the TED Talk? I'm just
was actually
Yeah, it's at 2007.
yeah, that's a while back. It's
almost 10
It's not
years.
a new technology. People have been, and if you go and just go into DNA Origami on Google, you'll see thousands of pictures of things that they've done. I said at first I think it was a novelty. Can we do this? And then once you have it out there, what can you do with it, and what can you build? What can you build, and what uses can it fill?
right. Instead of programming iPhone apps, maybe you're going to be programming organisms.
Yeah, it's amazing.
It's a language, right?
Yeah.
Right.
So
Absolutely.
that is what we got for you tonight. Once again, as always, send us any of your thoughts, your comments, anything you'd like us to look into, and we will definitely get on that. Anybody have any other thoughts they want to say before we sign off? Thanks for joining us, Doug, and Matt's
Thank
get
you.
better.
Yeah.
We'll get you,
Said
kid.
we'll be
Thanks.
watching.
All right. Thanks for tuning in.